Hey everyone, welcome to this week's episode of Solidity Fridays. This week we have an internal one joined by Tamara and Ryan, and we'll be looking through the Mud framework by Lattice. So I'll hand it over to our experts in the house because I'll just watch along today.
Right, so I think I'll give it a little introduction on it. The Lattice framework came on my radar earlier in Jan, and it's a pretty interesting new take on how we manage like storage on Solidity. So the idea is that it's like a different kind of OS for on-chain state, but it's not just like on-chain contracts or whatnot. Their actual development framework is one of the most like black magic witchcraft looking things that I've ever experienced. And you'll see what I mean. So glad you didn't look too deep into it, but I think what we'll do is we'll go to the Lattice Mud GitHub and just install on your machine so you can have the same wow that I had. And then after just seeing how it runs, so I've kind of done a lot of extensive looking into how it works because it's designed for games. So they initially built it for OPCraft, which is a all on-chain Minecraft. They even have a noise generator contract. Like they did noise generation on chain for procedurally generated on-chain games. It is wild. They basically started building normal Solidity stuff, and then it was just not terribly cost effective or efficient, so they just built their own system. What's wild is that so it's built out of Foundry and Next.js and stuff, but it denotes everything in schemas. So you write your schema and it auto generates the contracts and the interfaces. Its events are in like relational database structure. So you just wire that up to a relational database as like an update, and then a normal game dev database has its data in a form and schema that it understands. It's wild, it's ambitious, and it works. I may or may not have been the love at first sight was just running the terminal. So I think maybe we'll share your screen and then just like go through that, and then when we're done with just the initial setup, we'll dive into the actual contracts it uses, because in there it is wild, because they basically wrote their own way to do the storage. So the whole system is just all of these sort of behind the scenes storage systems that auto append, and there's a bunch of YUL somewhere. It's pretty cool. I mean, it is very Web3 to be building games using React and working more on the well, it's not all React, but like I've been working on a Unity SDK for a while on the gaming side, and there's you compile down, you do like WebGL, and there's some limitations there. So it's interesting to see what's being built like as web app focused only. So I mean, there's obviously native, but I haven't looked that far ahead. I was just like that. I started looking at the contracts, and then I got lost for a few days. But yeah, so
okay.
All right, let's just hit the documentation over there.
Yeah. Cool. I'm really excited for this one. I'm going in completely blind, to be honest. So I'm really glad you've had a look, but we can figure it out. I thought it would be cool to experience the installation process and all of that as with fresh eyes. Cool. So yeah, it's a framework for compressing the complexity so as you said, built for on-chain games like Dark Forest. I'm such a fan of Dark Forest. Such a fan. It's such a cool game. Cool. So some of the difficulties they say with on-chain games are coupling of state and logic in smart contracts makes upgrading logic difficult. Yeah. Lack of synchronicity between the chain and the client can lead to inconsistencies in game states. Irregularities with access controls pose problems for the would-be third-party developers attempting to create their own plugins and clients. Yeah, that's very true. Okay, cool. I would be keen to do another episode on OP Craft itself.
That sounds
and
great. Yeah,
entirely
I think we
on-chain
should.
craft. That would be epic.
Yeah, the way they did the procedural generation on that with the noise generator is nuts. So I think like it's probably worth an episode.
I would love that. Yeah. And it was built in 1.5 months, they say, which I think if it was not using mud wouldn't be possible.
That is literally why they built it. So they were trying to build it in the first place, and they were just running into issues. So they just built a framework for themselves. That's why it's like it Minecraft, and then they built mud, and that's why it's called Redstone. So like the other project is
That's so
Redstone.
clever.
I haven't looked into it too far, but I think Redstone is a deployment system
I looked into that.
But as a person who played far too much Minecraft, love it, top tier. So
Right. Should we go to protocol and where to store maybe?
Yeah, so
Store is an alternative to Solidity's storage engine, and it enforces a data model that can be mapped directly to relational databases, which enables atomic indexing and packs data more tightly than native Solidity. I would love to see how they got that working. This is really cool. I mean, it has so many applications aside from games. This is really cool.
I mean, if you think about it, yeah, sure, most people have heard of struct packing, but like for the most part, if you're defining even just one damn variable, half the time, like even addresses, the amount of wasted bits in just an address. But if you make your byte string and you know exactly that the first to the 64th bit or whatever is address, why waste the storage space? And you will never use that unused part of the address. Like it's actually bizarre. So yeah.
Okay, so it's much like a database, I think. So each piece of data in store is stored as a record in a table. Relational database, or you can think of it as a key value store, right? So to read and write data, we'll use the store core library. Okay, and then the interface to expose those methods to external callers. So that's pretty normal Solidity. Access control, obviously, because these are your callers for your data, very important. And then they say that the access control mechanisms are provided in world here, which hopefully we'll get to after I install everything. Cool. So store automatically generates a library for each table, which acts as a type wrapper. Okay, that's epic. And then obviously you'll just extend that library with access control.
The interesting thing is it's generated from the schema, so it makes the writes and stuff automatically. But I think the main thing with its syntax is often people who are good at building games don't have experience writing smart contracts. So the syntax that they use for like dealing with this, I mean, sure, you still need to learn a lot of Solidity, but when it comes to like critically focus on chain games, I think this makes it a bit more approachable for someone who see, if you want to build like a very crazy 3D game, perhaps I've been trying to figure out how to see how this would work with like a typical game development thing, but for they certainly have a specific niche of type of game so far. And I think it's only a niche because it's new, not because it's like esoteric. But yeah, I think it's a very interesting sector of the gaming thing to focus on. But but yeah, I haven't looked into it too far beyond that. I've just been oogling at contracts. So yeah.
Cool. And they have they use something called store encoding. So this must be how they encode it differently to Solidity. So it's comparable to ABI encode packed, but they don't use padding. So this might cause elements to wrap around 2 storage slots, but saves a lot of space. And we'll look at that now. So an address array with 3 elements will only use 2 storage slots in MUD instead of 3 in Solidity. Wow, that's cool. And an array lengths are packed into a single slot. Okay, cool. And then they go into the schema, but I think that's a bit beyond the scope of this. I'm going to keep this open, maybe even bookmark it, but maybe that's a bit beyond where we are right now. So then they show an example of how to read and write data. So you can use a getter to get from the library the storage, the storage data. And then obviously a setter that will be access controlled to set data. Cool.
So one thing to just mention about when you...
Automatic.
Sorry. The one thing to mention about when you do set it up, it does actually give you a full-blown example of this. So you might not need to read the docs straight up, because it gives you a much like when you set up like Foundry or whatnot, you get like a counter contract. They did a similar thing where they set up a world, they set up a test.
Yeah. Okay. That's epic.
Sort of,
that makes sense. That's really cool.
You're going to see a lot of black box witchcraft going on.
Cool. So then maybe we should pop into the README and I should start installing this epic thing. Cool. I'm very excited. Epic finder. Okay, cool. Okay, MIT license, open source, and free to use. We love those 3 things. Well, the first 2 are kind of the same. Cool. Quick start. So I suppose I need to install it.
So if you don't have PNPM,
I do. Have
so
I can just go create.
It's just like, they literally have a create setup. So cool. Everything but npm can run that command.
Okay, sick. How do you make a new window? So I just do this.
Just pick a folder and have at it.
Yeah, let me actually pick this folder. You're right. I was just going to be completely wild. Actually, I'm just going to be completely wild, and I'm going to call it.
Yeah, we just out here. We're bleeding edge tech. Throw it anywhere. Let's go.
Yeah, I don't really want to show my file structure on TV on
That's
stream.
fair.
That's cool. I should have prepared some. So I'm doing this. It's doing some stuff.
Terminals. Look at it go.
We love them.
Right,
cool.
So let's just go with React over there.
Okay, React.
Only to show you how black box witchcrafty its setup is.
Cool.
Let's try that one. So now it's going to set up like a next. I think it uses next. I can't remember.
My cat's going a bit rogue over here, but he has food. He just wants love, I think.
I'm not sure what the command on PNPM for that is, but
PNPM catnip.
So there we go. So it tells you to go into the folder and just do the thing.
Okay. Let me just move my screen a bit so I can. I wonder if they use Turbo for this. Okay, well, very black box.
So now you see on the processor there, it uses I can't pronounce it. It's like mprox or something, but it basically runs multiple terminals in this viewing terminal, so you can have like one just for interacting, so you don't have to open multiple terminals. It just manages it. And it's click. You can like click on the different things and tab through them.
Oh, cool. Whoa.
So if you click on the client, you'll see. So contracts is the forge side, and it has a watch that then generates with, I believe, Wagami, the types directly into the React side.
Oh, cool.
And
whoa.
like, yeah, so.
Is that done through a cogen, or is that, I guess we'll see how
Yeah.
done.
So now I'll click on the client thing on the processor there. And so.
Okay, cool.
What's it complaining about now? It'll probably reload. Yeah, it was probably just a false thing. That should be there now, but
yeah, cool. Otherwise, I could go S for start.
Oh no, it's already started.
Oh, cool. So this is started.
So if you just reduce this a bit, and let's go to the file structure. Right.
Great. So we are in my things anyway. Yeah, I trust these guys. Cool. So we have
packages.
Yeah.
So you got the PnP workspace, and then that mprox thing is how it actually does that like multi-process terminal thing.
I see. That's cool.
Yeah.
That's very interesting.
Yeah, it's annoying.
Okay, and then it's not turbo, it's a shell command, pnpm run dev for both contracts and clients. Nice. I've been working with turbo, so I'm used to when I see.
Oh, I was looking into turbo recently.
Oh, cool. We must have a chat this weekend. Should we look at some of the contracts?
Yeah. So the most important part is if you go down there, you'll see mud config. It's in the root of the above package. Yeah, there we go. So welcome back to relational database nonsense. So the tables are kind of like your, it's your data. So say you want to have users. Instead of writing a mapping, you actually just go user table, and then the value schema, you can say, created at, and you define the type. And when this is running, if you edit this, it auto-generates and republishes the types and setters and getters and all the eventy nonsense directly into the React side automatically.
Wow, that's cool. That's amazing. How do they do that, do you think?
I'll show you. It's witchcraft. But the other nice thing with this is, say you're looking up something that is a reference to another thing. You can actually reference the different schemas to do that, and then it automatically builds that. So if we go to source, so open up source there, just on the script. So you got the code gens, and then you got the systems. So let's look at the systems first, because once we get into code gen, that's like
systems. Yeah.
So remember we had a task table.
Sorry, I'm going to make this easier to
see. So basically, so we have the table that inherits system. So you have basically when you deploy a world, the world contract's permanent, but then you can have these different systems. If I am correct, be added in later on. I think there's an aspect of extending functionality later on. But
that's cool.
If you see here, you have tasks, the table you had, and you're setting it, and you just put the key, which is the lookup. And you can also say, it's just a hash. So it's all data hash table stuff. But literally, that's you setting a row in the database. And
wow, that's cool.
It's
not simple.
So you'll see when it's when we actually open up the web page, but let's open up the code gen just to show you what is automatically done for you. So let's start with the index.
Okay, so this is just an importer. Which will probably be in
this should look very familiar to most people.
Yeah.
Yeah. So now we got
a world.
We
go to tables or world. Okay, cool.
Yeah, world. So it automatically. So we have the world. So now this is your base. This is like your root contract. and it builds all of this directly. So,
Wow. And so quickly. That was really fast.
Well, it's Foundry, so
yeah, true.
We haven't added much to the world, but when you see the table, I think the table's where it's going to start getting a bit more interesting because, yeah. So,
we should have
like they said,
where we make a whole world.
Oh yeah, it's yep. So remember they said they built their own storage system. So it automatically figures out what flavor of storage you're dealing with, imports whatever is relevant, and when you start seeing how it does all of that, so there is also for certain kinds of data, it actually automatically makes a key, relational data database kind of stuff. So if you don't specify a primary key, it does it anyway. In certain cases. So we start getting into the woods where there's a lot of bytes. So if you scroll down a little bit, we'll start seeing a lot of so it's all libraries as well, which is quite nice. But so now all of this looks kind of straightforward. You got your register tables, and it's just a lot of functions, and it's like, what do these functions do? And we'll actually go into what the SDK has written. It's actually in the Foundry libs, if I'm correct.
Cool.
So
that makes sense.
But yeah, I think what would be interesting is to show you what the front end looks like for this, and then we'll edit the schema while it's running.
Right. How do I get to the front end? Is that well, obviously it won't be in source or contracts or package.
So in the roots, just open a terminal and just do PNP.
Oh, because it's and because it's 3,000, I think, or 3,000.
Hopefully it doesn't conflict with the last one. And it's doing the thing. Deploy scripts, all sorts of nice things.
I'd actually love to see their deploy script. Post deploy, they don't any. Oh, their deploy scripts in the SDK. Cool. And now.
So go to client. And just open that thing. Oh, it uses Vite.
Oh, sorry, I opened it in the wrong screen. Bringing it over. Oh. Minimal mud client.
Ta-da! A to-do thing, but it gives you an entire
blocks
terminal.
Are going. That's cool.
So now, it also you can see it from the context.
Is that the front end?
That's a front end. They built an inspector.
That's so cool.
So yeah, it now tells you the actions. So when you see the table data there, you see it will have like value, and this looks like bloody SQL. Like
it does.
So you pipe the events as they pop up directly into your SQL or whatever it is. So if you're running like NoSQL or something that is, I don't actually know what is more performant for games because they're normally everywhere. But yeah, it's pretty wild. So if you open up a summary there,
sure. I clicked on something, so it might be a bit different.
Yeah, so you see the to-do thing. So let's add something to that to-do section with the input on the left. So kind of to-do, check to-do. Stream things. Then it's mining, popping, and that's
crazy.
And now you can remove it. You can delete entries. You can edit things. So let's check that.
I don't have a doc, so I'm going to delete that one.
Yeah. Delete task. Boom. There. Keys. Remove.
You can put feed.
This is so cool.
So now if you go back to your terminal, you can actually see what Foundry is doing on that side. So click on contracts. Wait, the terminal. Oh no, I mean in the terminal.
Oh, in terminal, sorry. Contracts.
Yeah.
Here's some stuff.
Yeah, so I think they have some extra. I can't remember if they're doing extra stuff in there. So let's go back to that schema, edit it, and you'll watch all of this just update.
Gosh. Is our schema our codegen table tasks?
No, go down.
Right.
I think it's in mud config.
Oh yeah.
Right. Yeah, there we go. So let's add.
In a
so
value
in the
schema or
task,
something new? Yeah.
In tasks value schema, let's add maybe a string. And let's call it a.
Maybe urgency. Because this is for a task here.
Yeah. So urgency, and then find it as a string.
Or a UN256 could make sense. Cool. So
and
now.
Hit save. So now you can check the contracts terminal. So waiting for file changes. Ooh, what happened there?
Oh, error running forward build. What did we do?
Oh, we might have hit save before it was. Here's the fun thing about this mprox thing. So click on the contracts in the process there. So you'll see now it's highlighted. Press R.
Cool. Oh, this is quick. I've never seen something like this.
I know, like I saw this and I completely lost my mind. I'm like, what have I been doing?
Yeah.
Oh,
this is really interesting for big systems. I
might have got my.
Wait, here we go. Wrong argument constructor. Oh, so because
we have
over here under set, now we have to add. We also have to set our urgency.
So
it's just normal Solidity errors here.
Let's go to your sources. So the actual contracts. Under systems. So we changed the schema, but we're trying to save schema. Well, urgency would be. Yeah, we just need a colon there, and then we're good. Yeah, so that one's chill.
Okay, complete task is the same, I think. Let's see which ones need updating.
So without needing to update like the front end, let's leave it like that.
Yeah. Okay, cool. So now press R again, hey?
Yeah. Now normally it's a bit more lively. I'm trying to remember all the steps. I followed a video to do all this. What's it called?
Because our deploy script's now deploying.
So basically, we have to just restart the mud. Oh wait, never mind. No.
I'm just updating the deploy script because we don't have a. What happened here? Oh, I made everything a string. Let me get rid of this. Oh, maybe it's because there's a space there. No.
Okay. Now we're back.
So completed at, and then we set the urgency. We chill. This has been happening with me in Foundry lately. Though. Like this should work. Wait, we need one more of these boys, or one less.
One
yeah, more. That. Oh wait, maybe it's.
Yeah. Aha. Wait. So I think we've gone too far. Yeah, that is
okay,
pretty
so
bizarre.
So this is something that's been. So wait, I just want to check. There's one of these. There's one of these, and then there's one of those. So that's actually the right.
So I think urgency.
Yeah. I guess
And there you go.
urgency wrong. And then, so
Yeah, I think
I
it will
think this will
probably be
actually
fine.
work. Yeah, I've
Yeah.
been getting this where if you put, like, another day I had a contract, I was using ERC 712, and I put in like the
Yeah.
version, and then everything went this color for in my ID's string, but it wasn't seen as a string, it was seen as valid solidity. We can try again. Let's go R.
Yeah, so the post deploy is usually like where you'd put your application specific deployment stuff. So
yeah.
So
Yeah, so the deploy is
for example,
general, and that's obfuscated, and then we'd put our own,
yeah,
like our stuff for now, the urgency.
yeah, you
This
can kind of think of it a
is
bit like
working.
those. Oh, there it goes. Look at it go. Right. So now if we go back to that front end, we haven't edited the front end, but I know this is Solidity Fridays, but we might just take a look at some React.
Let me just go to
Where do we go?
what's it? 3000.
Local 3000. Yeah. There we go. Right. So, do anything.
Okay, I'm gonna delete walk the dog.
Yeah.
Actually, no, I'm gonna add something because we're gonna have to add an urgency to it. So stream Solidity Fridays, add.
Yeah, so we didn't actually put an input to change that, but because remember when we edited the task in the system, we didn't actually add another parameter for that.
Yeah.
So you'll see that
But that would
add
be
task
easy to
there.
do. This is so simple.
Oh no, it's almost brainless to do. It's great. So, but if we actually look at the store, you'll see urgency chill because that's what we wrote in the task system on the Solidity side. So if you open up the table section, sorry, on the tables tab, you see on the right-hand side, ta-da.
Urgency chill. Cool. It's a Friday. Everything's
chill. And like
this is cool.
The other thing is you can just keep adding tables, like things to the tables. Like so for example, if you wanted to have one table for tracking users, then you'd have like all your user-based stuff. Like if you want to do, say, if they have roles, right? Like say you're doing a guild system, you would then have the right only by writing in your schema that referencing the user table, you reference the guild table. So you can actually have those two things. So you have users, and then you just relation the user back to the guild table, and it automatically does that like lookup linking stuff. And then it gives you a library of your functions for your data storage to write your task systems with. It's I mean, like I would love to see. I would love to, what I actually kept thinking about was, what if I try to write this only to do DeFi things, like not like because a lot of terminology, world systems, that's very game language orientated, but I would be deeply fascinated to see someone like implement Uniswap in this and see what that, because at the end of the day, it's just tables, right? So like, world is basically just your database, and then you have mutations in the task systems, and the storage just does storage shit. Like, so you could probably, if you were to do like a Uniswap in this, it would be great because you have this front end tinkery thing. So you could build a whole like form submission Excel data capturing nonsense out of it, or if you have like the Uniswap, like post a trade, you can watch all the trades post straight in there. Because if someone's running an instance of your code against the same, say, Anvil in this case, and they just point to your deployment of it, you'll be seeing all of their stuff on here as well. So if you were to run this against, say, a live chain with this debugger view, you would see live instances because it's piping from there. So
that's so awesome. Wow, it's almost like a built-in indexer for your table, for your data. Like you could see pools changing and all of that just in the front end. Then it's so easy. Wow. This is so cool.
So I think like before we go into their actual, like what their storage contracts actually do, let's take one small glance at the actual like Vite React side, because it does a lot of nice things for people working on the front end.
Should I go to the repo for that, or should I?
Yeah, I just go to the code in the Visual Studio. So now in the code side, open up client there under now source. So now you'll see the mud context there. So this thing's sort of auto generated.
But this one is editable.
And yeah. This one you can add your own little niceties in there. But that mud thing under source on the left, so the mud folder. So this is kind of what it does for you. So create system calls. Let's take a look at that. So
it uses VM, not WAGMI, I think.
It is remarkable how many places are using it. Like I still remember when I first started looking into VM, and it's like a whole different way of thinking as a front end user, because it's all hooks and nonsense. So now like WAGMI 2 decoupled their querying thing, so you can actually like set the check interval and stuff. It's wild.
Oh, cool.
So I'm trying to remember where we write our logic. I think it was in. Actually, scroll down. I think you. Yeah. Okay. Yeah. Here we go. And there's a task.
Yeah.
Yeah. So the functions we wrote in the task system are now accessed in the front end like this. So you go world contract, write the task. Ta-da. And then it uses TypeScript, so it already tells you like what the inputs are. So even if you're not the smart contract guy, fill in the blanks and hope for the best kind of thing. And yeah. So if you were to write like all the actions for your game or whatever, like, or interface, like submit trade or vote on thing, you would write this.
Yeah.
And all smart contracting nonsense, critically, you haven't seen an ABI yet.
No,
the word
and you may
ABI
have
contract,
to.
none of that it hasn't happened. It's just like, right, world thing, great. That's like, if I'm just a front-end person, it's like, right.
You can do the smart contracts through this almost.
Yeah, so if I want to read, I just go read, and then it tells me the read function's available,
cool.
and I fill in the blanks it asks for, and then I'm there. Like,
yeah, epic. So here, I guess I add task, we would add another parameter of urgency string, and then add it here.
Yeah, but we didn't. We'd have to.
Yeah.
So in the task system, you would edit it there, and then when it compiles it, because if you scroll
this would
up,
get
right?
autogen. Yeah.
Yeah. So if you scroll all the way to the top, you see where. Wait, where does it get the world from? Scroll down.
It might be from setup network result.
Yeah, I think it's somewhere at the.
Yeah.
So
world
it
contracts
pulls those things in
from setup network result, which is here.
And yeah, let's take a look at that. Well, it's actually wherever they call that setup. It's probably at the base of app, but they're using RxJS. Interesting. Cool. So this is all the Veeam. How do you even say it? Is it Veeam? VM?
I say VM, but I am notoriously bad at pronouncing these things, especially on Solidity Fridays.
If anyone in chat wants to write some pronunciations for us, that would be great.
Yeah.
And they use ZooStand.
I don't know what that is.
So ZooStand is a minimalist version of Redux. Now, Redux is finite state machine. The difference is that ZooStand is like very minimal, whereas Redux is pretty chunky to shove into your front end. But what's interesting with this is that that's why their terminal window works. So ZooStand using Veeam can actually wire up to the block updates to then pipe reads into the state change directly. And because it's decoupled from the front end, it doesn't automatically cause a refresh. Because that was normally the problem if you use like a context approach, is you're getting all these wild, questionably lined up updates. Whereas if that's why a lot of blockchain apps lean towards these state machines, because the state updates a lot more than a normal web app. Which causes a lot more refreshes, which things get questionable.
Okay, yeah, and you want to control the order of those.
Yeah.
Interesting, thanks.
How about we take a look at the actual MUD contracts? Because I think if we start looking at too much React, we'll be here for days. So let's go to client, the contracts. The contracts fold. Yeah. So under there, go to lib. Wait, where's lib?
Maybe it's a node module.
Yeah, let's go in there. So let's open up the world there. Open that up.
It might actually be a world module, not a access control, create two module. Yeah, I'm not seeing MUD. Maybe it's under world, this one. Because it's used by no MUD.
So
we could also go to the to GitHub. Where is it though?
Yeah, we could actually do that. That's probably a bit more straightforward, because that's actually where the code is.
Yeah. Is it? No, I'm just curious though. Okay. Oh, they use 165. Okay, sorry. I'm getting distracted. I can do this after the show. So wait, where were we looking on the page with all the these ones?
It's been a while since I think we did like a live stream discovery Solidity Fridays, which is cool.
Yeah.
They're using Turbo.
Love to see it.
Yeah, I was actually so I was trying to tinker around with this mprox terminal thing.
Yeah.
And it was like super cool. And then trying to put that on Vercel was an utter nightmare, because like everyone recommended Turbo, but at that point I'm like, I've just learned like 5 separate things. I'm tired. So where are? Oh my god!
I know. I tried to go into STD contracts, but that didn't work. Store maybe or
world
modules.
So let's go to world at the bottom there. So if we go to source, we should see.
We were just looking at this.
But
world.sol maybe.
Yeah. So if I recall correctly, there's a concept of world, systems, and modules.
Okay.
I
actually
think modules
in here. I'm gonna go back here because this is sorry, it's too bright for me.
Yeah, there we go. Yeah. So as you can see, there's quite a lot. That's a lot of imports for a contract that apparently is space saving.
Yeah.
I would actually all of this is nice, but I haven't actually checked how much it costs to deploy these things.
Yeah, well, they have a gas report in their repo, so it'll be interesting to run and see, and compare to if we had the same variables stored in normal Solidity. It's probably more costly to deploy, but cheaper to run.
If I recall, the upgradable concept was you have your world, you can't change that. You can add and use system, and then you can add more modules to a system, if I recall correctly.
Okay. So it does get a bit modular there, where you can add like fine-grained functionality.
Yeah, so like if you think of it as you could add a module for gameplay where now you have crafting on top of the inventory system. So then that will manage like publishing new items if the crafting module checks that you own those things in the inventory table. So you could plug that module on when you want to do crafting on top of the inventory system, for example.
That's really cool.
So okay. So this looks normal. We have an actual hello world. It's the most valid use of hello world ever.
Yeah. That's hilarious. signature. Why is this here? Oh, it just returns the version. It's just, I don't know. I'm not liking having
there's
a pure function that's public but above my constructor. But
I
get
think
it.
like
You want to see the version easily, maybe.
I think they also went with what is more expected by not Solidity people, like
which is fair.
good. Like I mean, when you're trying to keep track of all the auto functions thing, like the modifier should be up there, but yeah. So I think let's take a look through this. But then my thinking is their most critical thing is that they change the storage state thing, right? So we might want to go look at. Actually, they talked about arrays. We should go see how they do that. So if we scroll up this page, I think it
imports it.
It will tell us where. Yeah, at the top there.
Store data and store call. And that's in Lattice, Smart Node Modules, Lattice. Wait, here. Store, source.
Yeah. Okay. Is there an array? Probably storage. Yeah, I think all arrays are just considered bytes at this point.
Okay, that makes sense. And then they do bit mapping. Yeah, bytes to bits constants. Cool.
Yeah, this looks like the thing.
This is the thing. Cool. Low-level storage manipulation. Cool. Store a single word of data at a specific storage pointer. That's cool. So you can set the storage pointer, and it's just an store. So that's just regular assembly. But now here we get the offsets and the fun things. Store bytes of data at a specific storage pointer and offset. So that's where you could do your own struct packing. Well, not even struct packing. You could do any kind of packing.
Yeah. And because they have their own pointer management, that lets them skip over all the padding. Because now, as long as you record the pointer, like you don't need a whole like you don't need the whole bloody like slot if you know that it starts there. But those paddings are just so that we can assume that thing is this big because it's this. But so the way I felt about the way this is working is that is a huge improvement on how we do like just storage at all right now. But I never thought that the next step in storage improvements would come out of the language that causes them. Right? I thought it would be like a different language that has this built into it,
that comes and revolutionizes
Solidity.
Yeah.
Because like Solidity is the thing that creates a uint256 as a full byte. Like this is the language that does that. So the fact that they use the language to basically usurp its own protocols is, well, I mean, granted, they're basically writing YUL for the most part. So technically,
yeah, they're almost writing YUL. I expected to see more assembly, but
it's YUL in sheep's clothing.
Yeah. Cool. Here's some assembly.
Right.
Yeah. Okay. This is really interesting. And then they have 3 different store functions in this contract, and this one has a storage pointer, offset, length, and a memory pointer, which is the start of the data in memory. And the offset is the offset within the storage location.
Oh my. Yeah, we're getting into
word. This is really cool. Level.
So a bit of a sidetrack, and I won't ramble too long. If you've ever wanted to be game devs of ye olden times were some of the most interesting folk when it comes to like making code more efficient. My favorite video is how they achieved Crash Bandicoot, because it was like the first time in games that they implemented page. Because Crash Bandicoot had more polygons than most levels. Like the entire, because all the levels were loaded directly into memory at the whole time, but Crash Bandicoot, because they wanted to have a Looney Tune-esque animated character, most of what would normally be a level was just Crash, and you only see the back of him. So they wrote their own paging system, and there was a lot of interesting things that had to do with the low-level math there. So it kind of makes sense that we're seeing this kind of deep math bite nonsense from the, like, functionally game. They were trying to build a game, so they did this. Like, it sounds identical to what the Crash Bandicoot people did.
Absolutely, like the storage advancements of Solidity is coming from the gamers or the game devs. Oh, that's epic. Cool, and then you can zero multiple storage slots. This is really cool. Yeah, I'm keen to play around with this and see what I can build that's not a game and how it fares, and do some gas comparisons.
Yeah, like, I didn't want to dive too deep into it because, as you'll see later, there are so many contracts in this framework.
Yeah, and they're all these modules, and there's so many of them. Yeah, so we won't have time to go into all of them today, but it would be cool to look at how it's applied in that OP game.
Yeah, so you got OP Craft, but then there's also a couple big games that are going that I can't remember if they are in production, but like they actually, like, their Discord's quite nice. Like, they have a lot of the different projects and teams, like, showcasing stuff.
Oh, cool.
And they're pretty active as well. Like, their YouTube, I think it's like a video every other day. Like, they're a very active team.
Awesome. It would be cool to join their Discord and watch out for all the cool on-chain games that are going to get released, if you're into that. So is it the Muds Discord, or is it the Lattice Discord?
Lattice Discord, yeah.
Okay, Lattice Discord. Nice.
Yeah, because I think they just had their core devs call, which means that they have a lot of, I'm assuming, third-party external collaborators. So
I would imagine so.
I'm really curious to see if people are using this framework for, like, not games. Like,
I doubt it yet, but maybe, hopefully after this video, people get inspired, and it would be cool to implement, like you said, something like Uniswap, and then compare the gas and storage usage, and then see. It might actually have a lot of use beyond games.
I just had a thought. And I won't ramble too long on it because I realize time. So when it comes to, like, bridges and whatnot, right? Like, if you're going from, say, Solana to an EVM, we have a critical divergence of how state and stuff is managed, right? If we are writing in a unified storage pointer way, it's the same.
That's interesting.
Like, it's the same. Like, you can write all of this again, but you're not going technically through the Solidity piping into the bytes. You can do, like, all of this kind of uniform, because it will be the same byte output no matter what language or context.
Yeah, that's the beauty of it. That's an epic application. You're right.
That is a very cool application.
Good God.
Cool, man. I really enjoyed this episode. Thanks, guys.
Yeah.
Interesting stuff.
Yeah. Thank you so much, Ryan.
Fun.
Thank you so much for finding this protocol and leading the way. I think it was very cool.
The pleasure was mine. Don't worry.
Cool. Then, yeah, thank you everyone for joining. We will upload this episode hopefully today, but if not, soon, and on YouTube. But yeah, you can catch us next week. And yeah, this is supported by Web3 Sanctuary and Linum Labs as well. So thank you so much, guys, and we'll catch you soon. Bye.
Cheers, gang.